So in this topic we'll discuss about how to calculate the energy balance for the atmospheric distillation column. Now let us look about the calculations of energy balance and what is the required parameter for the calculation of energy balance. So energy balance, or you can say the heat content, it is represented by Q value. It is expressed in terms of the BTU per hour, that is the British thermal unit per hour. And how to calculate? We know a very famous and very popular formula, Q is equal to mCp delta T, where Cp is the specific heat, delta T is the temperature difference, and m dot is basically the mass flow rate. So the second formula where Cp and delta T, the both are basically incorporated by a single term, and that term is a very famous term that we call it is enthalpy. So we can summarize this formula as Q is equal to m dot H. So where H is basically the enthalpy of the fractions in the hydrocarbon at a particular temperature in terms of BTU per pounds, and mass flow rate, that is the m dot, is given in the pounds per hour. So basically here the second formula, that is the m dot H, we are going to use this formula in our energy balance calculation, in our heat calculation. So it have two terms, one is mass flow rate, second is enthalpy. So as we have already calculated the mass flow rate in material balance, we have completed that mass flow rate. The second thing, that is the enthalpy. So this is the remaining parameters for the calculation of heat content. So in this lecture we are going to discuss how to calculate the enthalpy, that is for the energy calculation, for the energy balance in the atmospheric distillation column. So for the enthalpy calculation, this is a step that we need to know, and we need have three informations we require. Number one is the temperature at which the fractions of hydrocarbons is available. Number two is the API of the fraction, and number three is the phase of the fraction, either it is a liquid or gas phase. So if we know all these three parameters, after that we can use a chart, a graph, for the calculation of enthalpy. So it is a graphical method to calculate the enthalpy using the temperature, API, and the phase. Now let us look example. This is basically the graph, enthalpy graph. I know it looks like slightly complex, but it is very easy to read. So let us take x-axis. This x-axis is basically the temperature axis. The temperature of that is given in degree Fahrenheit. Unit is also very important in the reading of all these graphs. Y-axis, our desired axis, that is the enthalpy in BTU per pounds. And then we have different lines. These lines are the API lines, but these lines are the API lines, but for different phases. For example, the bottom portion, the bottom portion of these curves are liquid phase API, and the upper portion of these curves are vapor phase API. So if you have a vapor phase, you have to find out, you have use these lines, and for the liquid you have to use these lines. So in this way we can find out the y-axis, that is the enthalpy. Let us take an example. For example, the temperature is given as 400 degree Fahrenheit, API is 30, and the phase is liquid. How we can got it? So the temperature is 400, then because it is a liquid, so we have to go for the lower portion. This is the first line is 0, second line is 10, 20, and the fourth line is a 30. So 10, 20, 30. This is a 30. So at 30 you can find out it is between the 250 and 375. It is about 275 pounds per BTU per pounds. This is the enthalpy calculation method. Let us take a second example where the temperature is given as 250 degree Celsius, specific gravity is given, and phase is vapor. So the temperature is not given in degree Fahrenheit as we required. Here the specific gravity is given, but we need a API gravity. So we have to convert these two values, and we can find, after converting these two values, temperature is 482 degree Fahrenheit and API is 34.97, that is very close to the 35. So now come to the again on graph, and this is about 480 degree Fahrenheit, and we have to come for the vapor phase, that is the upper of the upper lines, and then we have to find out the API. That 35 is very close to this line. You have to be careful about reading these values. These are very close one. So it comes around 450. So we can say the enthalpy is 450. So in this way we can find out the enthalpy of either liquid phase or vapor phase at any given temperature for the given API. These are the few questions that you have to calculate it by yourself. For example, in question 3, temperature is given, okay, phase is given, okay. So the turning point is all about this range of petroleum fraction is 12 to 20 volume percent of whole crude, and what we need API. So API is missing. We have to find out the API of this given one, and you know how to find out. In the question 4, temperature is given, okay, but it is in the Kelvin. It means we have to change in degree Fahrenheit. Fraction range is given here, phase is given, so the fraction range is given in the degree Fahrenheit range. This is, so you have to convert this range into the API. First you have to convert this range into the volume percent, then after that API. So that is the trick here. Now after that you have to also go for the calculation of Q value, that is a heat value of the given conditions. Temperature is given, phase is given, and the light naphtha, we know about the light naphtha. The API values of the light naphtha can be taken from the earlier calculations, then find out the value of H, and we can also find the amount of basically light naphtha and multiply that M value and then H value, that gives the value of Q. Similarly for the other one, this is for heavy naphtha, where temperature is given, phase you have to guess. For the VSO of heavy naphtha, means in the stripper where the VSO, that is the vapor strip out, is recovered, so you have to find out the API of that one, and you have to guess whether it is a liquid phase or vapor phase, and then again repeat the same task. After finding out the H value and you know the M value, just multiply these two values. Similarly the next one is temperature is given here, phase you have to guess for the stripped feed of the light distillate. Similarly for this one, temperature is given, phase is given, you have to find out for the heavy distillates. So this is all about, you have to do it by yourself and submit in the Google Classroom. Thank you very much.